My name is Tridib and I am a student of Master of Science Data Analytics in National College of Ireland. My topic for this research in computing is recommendation system for retailers. Every day with a huge growth of the business related data is also growing exponentially. Each and every day there are piles of transaction and data is recording in the database. The huge growth of numerous information brings about critical applications of internet. The amount of online contents have exponentially increased. Recommendation techniques have been studied widely to push sales of the business. As a consequence, customers as usual dashed into the ocean of information and couldn't find the information or the items which is what is exactly required. Recommended systems are software applications that backing users in finding items their choice within bigger collection of objects. Today, these systems are used in a diversity of application domains, counting, for example, media streaming, e-commerce, and receiving automated recommendation of diverse forms has been integral part of our everyday online user skills. Internally, recommended system analyze the past behavior of the individual users of a group of users as a community as a detect pattern in the data or any online site. Numerous types of relevant actions of users can be recorded. For example, that users views an items or click on a link or make a purchase. So in this research, my question is how deep learning can be effective in retail recommendation system rather than traditional methods. Most of the recommended system use either collaborative filtering or content-based filtering. Collaborative filtering works as a building performance of items with the users. Has described the first challenge in the scalability of the collaborative filtering algorithm, and the second challenge is the quality of the collaborative algorithm. To overcome this problem, they have used item based filtering, but in the item based filtering there are also some issues like data sparsity and cold start problem. So here the objective is I will compare a few traditional models with deep learning algorithms. As per the objective, I will implement matrix factorization. SVD will take the country as a deciding factor for the collaborative filtering. From this, we will try to evaluate whether clustering based on the country can help with the problem of sparsity. I will implement associated rule of the products like a priori algorithm. In the end, I will implement deep learning algorithm with this detailed source data and will evaluate which one works best for this kind of sales data. In my research methodology, I have used CRISP-TM method. So in this CRISP-TM, there are six models: business understanding, data preparation, modeling, evaluation, and deployment. As this is my research proposal, so deployment will not be there. So the first part is business understanding and requirement. To understand the data business is required to kept on the first priority. E-commerce, on the other hand, is the one pioneers in business in today's world. E-commerce sites and retail industry require a mechanism which is smart enough to advise related contents to customers in the process for this. The correct machine learning model for recommendation system is required for logically suggest these relevant items to the customers. The next part is data understanding and collection. As a part of implementation of the project, data has been collected from the competition launched by Analytics with the building a recommendation engine powered by IBM Cloud. In this data, there are 7 variables. Description of the variables has been given. There is a total of 330,575 entries. Mainly, this data is the sales transaction data, customer ID, and invoice ID are same, and the data type is int. Quantity and quality, unit price is also in int here. How many quantities have been sold and what is the unit price on items is given. The country has been given as a country code, which is a starting string data type, and stock code is a string data type as well. In the next phase, data pre-processing. To successfully implement the machine learning models, clearing the data is very much important. If there is any special character or null values, proper steps to clean the data will be taken. Other than this, if there is any correlation or imbalance present in the data, that needs to be checked, and if present, corrective measures to be taken. Customer ID and invoice ID are the same in this data set, and customer ID has given as per the invoice ID. So new customer ID column will be created according to the grouping of data. Stock code is given here as a string, so we need to create a stock ID in float data type. These two changes need to be done because in this case of matrix factorization using an item matrix will be created. String and int matrix cannot be created. So the first model is matrix factorization. In matrix factorization, characterize both items and users by vectors of factors inferred from item and quantity pattern. High correspondence between stocks and customers factors lead to a recommendation. Matrix factorization models map with both customers and stocks to join latent factor space of dimensionality F such that the customer stock interaction are modeled as inner products in that space. A recognized matrix factorization process is singular value decomposition, which is SVD. Ca- Collaborative filtering can be framed by resembling a matrix X by using singular value decomposition. Here, one orthogonal matrix will be created and another Y matrix which is diagonal and non-negative. So the multiplication of both those matrix will be a orthogonal matrix, and that will be the singular value decomposition of matrix Z. In the next, a priori can be a good choice in the case of retail sales data. Whenever we buy in a set of items. In this algorithm, set of items and buying frequency will be calculated. In this way, it will be created shopping pattern. So whenever a customer will buy an item, I automatically associate items with those items will be recommended to the customers. In the end, the recurrent neural network will be added here, and restricted broadband machine, which is two-layer neural network. One is visible and another is a hidden layer, will be factorized, and model is suitable in this kind of retail data set. So explicit column like rating of item is not there, so this will be a new way to handle sales transaction data. Generally, recommended system design is a three-tier design where application system data will be generated by the customers. It may be purchase data or maybe historical track data of the customers. Then it will come to a logical tier. By logical tier, it will come to the data tier. From the data tier, it will come to again logical tier, and where all the methods of recommendation filter will be executed, and the final output of the recommendation will show the presentation tier. But in this particular project, I will be using static data which is already stored in the database, and using the data as a recommendation engine is a popular at it with the result. Details architecture and architectural design has been given here. Evaluation can be done online as well as offline. In terms of the action methods will be different. Online evaluation is a constant process, whereas it is a build upon continuous feedback from the users. So there is a various way of evaluating the model. But in this detailed recommendation, customer interaction is not there. So the dataset will be static. So we'll implement only offline evaluation to analyze the performance of the different algorithms of the recommendation. A common approach of evaluation performance of the model that gives output set to make a confusion matrix. From this confusion matrix, we can evaluate precision. We call an F measures. Model performance will be evaluated through root mean square RMSE and mean absolute error MAE. Mainly, other than these common methods, novelty will be checked. Organization has become an integral part of e-commerce business. This is practically impossible for customers to find products and the products related to that of the same products with different brands. So a good recommendation system will increase customer engagement by providing customers relevant products and will predict the products what customers may buy. This proposal will experiment with the deep learning algorithms with a particular type of dataset, and as a learning outcome how to implement the machine learning and deep learning algorithm on the raw sales data set with the retail house. Now these various type of recommendation and the different algorithms has been used out of there. Three types of recommendation system has been introduced here. I have chosen three algorithms to work on will measure the performance of the algorithms. Though most of the algorithms have worked on the rating prediction and according to relate to the items. In this experiment, I will relate the quantity bought by the customers to deep learning algorithm, and if there is any significant improvement over the most popular algorithms like SVD and a priori. Thank you.